In this session, we will learn how to plot IV curve for photovoltaic cell based on the illumination at constant temperature. At the end of this session, you will be able to know the IV curve for photovoltaic cell, describe the equipment solar simulator, explain the characteristics of solar cell, detail on the IV characteristics of PV cell for variation in the illumination and the load.
Let us get started with the IV curve of photovoltaic cell. The solar cell IV characteristics curves shows the current and voltage IV characteristics of a particular photovoltaic cell, module or array. It gives a detailed description of its solar energy conversion ability and efficiency. Knowing the electrical IV characteristics, more importantly P max of a solar cell or panel, is critical in determining the device's output performance and solar efficiency. Photovoltaic solar cells convert the sun's radiant light directly into electricity. The graph shows the current voltage characteristics of a typical silicon PV cell operating under normal conditions. The power delivered by a single solar cell or panel is the product of its output current and voltage. If the multiplication is done point to point for all voltage from short circuit to open circuit conditions, the power curve is obtained for a given radiation level. When the solar cell open circuited is not connected to any load, the current will be at its minimum, 0, and the voltage across the cell and its maximum, known as the solar cell open circuit voltage or VOC. At the other extreme, when the solar cell is short-circuited, that is, the positive and negative leads connected together, the voltage across the cell is at its minimum, 0, but the current flowing out of the cell reaches its maximum, known as the solar cell short-circuit current or ISC. Here is the IV curve of solar panel. PV panels can be wired or connected together in either series or parallel combination or both to increase the voltage or current capacity of the solar array. If the array panels are connected together in a series combination, then the voltage increases, and if connected together in parallel, then the current increases. The electrical power in watts generated by these different photovoltaic combinations will still be the product of the voltage times the current. However, the solar panels are connected together, the upper right hand corner will always be the maximum power point of the array. A solar simulator is a light source that has specific quantifiable similarities to natural sunlight, namely in its spectral distribution and intensity. It may also be referred to as an artificial sun or sunlight simulator. The solar simulator has special air mass filters and lamps to simulate the sun's solar spectrum. The purpose of a solar simulator is to provide a consistent, controllable source of illumination in a laboratory environment for testing any materials or processes that are photosensitive. It is time to test your understanding. To perform the task, you need solar energy meter and the solar simulator equipment. Your first task is to understand the lab equipment solar simulator. Study the lab equipment available in shop floor to learn the IV characteristics of PV cell. Go through the manual supplied along with the equipment to know the different controls used in it and their usage. Learn the do's and don'ts. Get familiar with simulation with solar light's properties. Remember, technical circuit inside and its functioning not required for your study of PV cell. Common features of this solar simulator should be to simulate the sun, set of lamps are used as the source of light. To simulate the sun for its heat radiation, an electrical hot plate is used. To simulate east-west movement of the sun, the lamps are provided individual control. To simulate variation in solar irradiation, the intensity of the lamps need to be controlled. To simulate variation in temperature, the heat generated by hot plate needs to be controlled. The location of the solar PV cell is to be over the hot plate facing the lamps. A variable resistive load is required across the terminals of the solar PV cell to indicate actual load conditions. A set of digital, preferably voltmeter and ammeter, are essential on front side. Control of intensity and heat should be independent. Your second task is to study voltage, current and characteristics of solar cell. To perform this task, you need a solar simulation lab. Connect the solar simulator equipment to mains power supply and switch on. Set both the intensity controlled rotary switch of lamps at maximum position to get the full intensity. Measure the intensity using solar energy meter and record the observed value. Set the variable resistor load provided at high to simulate no load condition. Measure and record the voltage and current of solar cell at no load condition on display. The voltage displayed on voltmeter is open circuit voltage. Vary the load progressively downwards. Simultaneously measure the VI readings and record. The minimum position of load indicates the short circuit across the PV cell and hence the current will be highest. It is the short circuit current of solar PV cell. Plot the path of curve for recorded values of V and I to get the IV curve of the solar PV cell at fixed intensity. Your final task is to study the voltage, current, characteristics of solar cell with variation of light intensity and varying load conditions. You need solar simulator equipment to perform this task. Connect the solar simulator equipment to mains power supply and switch on. Set both the intensity control rotary switch of lamps at maximum position to get the full intensity. Measure the intensity using solar energy meter and record the observed value. Set the variable resistor load provided at high to simulate no load condition. Measure and record the voltage and current of solar cell at no load condition on display. The voltage displayed on voltmeter is open circuit voltage. Vary the load progressively downwards. Simultaneously measure the VI readings and record the observations. The minimum position of load indicates the short circuit across the PV cell and hence the current will be highest. It is the short circuit current of solar PV cell. Repeat the above with reduced intensity at different levels. Plot a graph for each set of observations to get the IV curves of the solar PV cell.
We have reached the end of this session on plot IV curve for photovoltaic cell based on the illumination at constant temperature. By now, you should be able to know the IV curve for photovoltaic cell, describe the equipment solar simulator, explain the characteristics of solar cell, detail on the IV characteristics of PV cell for variation in the illumination and the load.